I'm Algebra Annie, and I'm here to help you be successful in your algebra class. If it doesn't challenge you, it doesn't change you. Fred DeVito. Our learning targets today are: I can solve compound inequalities in one variable. I can graph solution sets of compound inequalities in one variable. We're now going to be solving compound inequalities. So a compound inequality is going to be connected by a word. For this particular problem, we're connected by the word and. So I want all the numbers that are larger than 2, and those numbers need to be smaller than 6. So if I were to draw a number line for all the numbers bigger than 2, here's 2 in question. It's open because it's not equal to. You need to color a few to the right and color a few to the left. What numbers are larger than 2? Well, I know 3 is larger. I know 4 is larger. Everything over in this direction is larger than 2. Well, what about numbers that are smaller than 6? This is my number line for numbers that are smaller than 6. So I need to find the numbers that make both of these statements true, because it has to work for and, both of them. So if we're looking at this, so using green, I want to color all the numbers that are larger than 2. It wasn't equal to 2, so it's an open circle, and all of the numbers all the way down there are all bigger than 2. Well, what about the statement numbers are smaller than 6? So 6 is the number in question. All the numbers smaller than 6 would have gone all the way down here. So I have green being all the numbers bigger than 2, and I have blue being all the numbers smaller than 6. It's connected by the word and, so it has to work for both of our colors. So where does it work for both of them? Well, over here I only see green. Over here I only see blue. So if I'm going to do my final answer, so here is my number line. So we use this number line to kind of think about it. Let's write the official answer down here on this number line. So 2 was one of the numbers being looked at. It is open. 6 was the other number being looked at. It is open. Where in our showing of the work did we see both blue and green represented? It was all in here. So it was all in here. So what numbers are bigger than 2, but also smaller than 6? All the numbers in between 2 and 6 will be larger than 2 and also smaller than 6. So you will notice that and statements always go between the numbers. And we're done. So our next problem is very similar to the one that we just did. I want all the numbers that are bigger than or equal to 2, and I want all the numbers that are less than or equal to 6. So you need to draw one big number line that would compare both the numbers 6 and 2. I want a few outside of 2, and I want a few outside of 6. So 2 was one of the numbers in question. So here's 2. It was an equal to problem. So he is colored in and he is a closed circle. 6 was the other number in question. So here is 6 equal to. So it is closed and it is colored in. Now the word and also means that we're looking for all the numbers between these points. So you would color everything in between. And go ahead and kind of think about it and check your answer. You said 4 was an answer. So is 4 actually bigger than 2? It is. Is 4 actually smaller than 6? It is. So you know you picked right. And you're done. Now we know that mathematicians are lazy, and whenever we can shorthand things, we try to. You see that we have an entire squished together problem with 2 different inequality symbols. When it's squished together with 2 different inequality symbols, this is going to be an and problem. So I see 2 problems right here. The entire first problem, red with the first inequality, is question number 1. The entire second problem, red with the second inequality, is question number 2. So you're just going to break it up into both of those problems. So our first problem was 4 is less than or equal to x plus 2. This was connected by a giant and, because if they're squished together cheating-wise, they're and problems. And the other question was x plus 2 is less than or equal to 8. I literally just wrote the first problem and then wrote the entire second problem. Now I have two problems that I need to solve, and I have to be very careful and pretend that they are two completely separate problems. Solve for this one by himself, solve for this inequality by itself, and then we'll graph them together like we have been. So going over here, I needed the inequality symbol to be by himself. I need the x to be alone. You pair this positive 2 with a negative 2 to make it up and disappear. 4 minus 2 is 2. I didn't do anything with this symbol. X is still there. A positive 2 minus 2 is 0. So I am graphing 2 is less than or equal to x. And now I got to come over here and figure out what else I am trying to graph. So on this problem, I need the x by itself. The added 2 needs to go away. So I have x is less than or equal to 8 minus 2 is 6. So 2 is less than or equal to x from problem 1. And x is less than or equal to 6 from problem number 2. Now, how do we rewrite this smooshed together like they tried? So we're both looking at the numbers x. So here's our numbers x. X was compared to 6. This x was compared to 2. Now we just need to make sure that we have the inequality symbols pointing in the correct direction. When x and 2 were being compared, right here we have x and 2 being compared, the inequality symbol was pointing to the 2. So our inequality symbol is pointing to our 2. Over here in this problem, when our x was being compared to our 6, which this is our x compared to our 6, the inequality symbol was pointing to the x. So our inequality symbol is pointing to the x. So these are the two ways to write your answers, and now we actually need to graph it. So here's my number line. I'm supposed to be graphing the numbers 2 and 6 being compared to one another. So I want a few numbers outside of both 2 and 6. So 2 is one of the numbers in question. It is equal to, so he's colored in and he is closed. 6 is the number in question, so he is colored in and he is closed. And if I have to meet both of these requirements, it has to be between the two. And that is my graph, and I am done. So now they want us to solve this compound inequality and graph it. So I see it's squished all together. The minute I know that it is squished all together, I am connecting two separate problems with a giant and. So I need to figure out what is question number 1 and what is question number 2. So question number 1 is the full problem that I would read from left to right before I ran into the first inequality symbol. So my first question is -5 is less than or equal to 2x plus 3. To figure out what your second problem is, you would start right after the inequality and you would read all the way to the end. So this is problem number 2. So problem number 2 was a 2x plus 3 is less than 9. So now I have two separate problems connected by an and statement. We need to solve both the inequalities. Then we'll come up with a new statement and we'll graph it. So over here on our first problem, if this were an order of operations problem, we would have to first multiply by the x, and then we would have added the 3. We are doing gems backwards. So we're doing order of operations backwards. So the first thing that needs to go is the 3. I pair a positive 3 up with a negative 3 to make it up and disappear. -5 minus 3 is a -8. Symbol stays the same. I haven't done anything to the 2x. Positive 3 minus 3 turns to 0. That's how you know it up and disappeared. Now I need to divide both sides by 2. The minute you divide, you're supposed to stop and take a look. This is a positive number. If we're dividing by a positive, we do not reverse the symbol. So I'm going to immediately come down here and write the symbol it's supposed to be so I do not forget and accidentally write down the wrong symbol. -8 divided by 2 is a -4. 2 divided by 2 is 1, so I'm left with 1x. So I have -4 is less than or equal to x. And now we got to figure out the new problem. So our next problem, order of operations would have said multiplying and then go ahead and add the 3. I'm supposed to do order of operations backwards. So doing order of operations backwards, I need to pair that positive 3 up with a -3. So I have 2x is less than 6. I need to divide both sides by 2. The minute you divide it, you need to stop and take a look. This is a positive number. If it is positive, we do not reverse the symbol. So I'm going to immediately write the symbol I'm supposed to so I don't lose it. 2 divided by 2 is 1, so I have x. 6 divided by 2 is 3. So I already have my first, and the second problem I'm supposed to graph is this one. Now, if I wanted to squish all of these together into one giant smushed problem, everybody is looking at x, so here's my x. X was compared to the 3, x was compared to the -4. When the -4 and the x were compared, -4 and the x are being compared, inequality was pointing to the -4, inequality pointing to the -4. When the x and the 3 were being compared, x and the 3 are being compared, inequality was pointing to the x, inequality is pointing to the x. Here are the new inequality symbols that we are trying to graph. We need to compare -4 and 3 on the same exact number line. So counting a few outside of -4 and a few outside of 3. -4 is the number in question. You circle it. -4 was compared with an equal symbol, so -4 is closed. 3 is the number in question. 3 is not compared with an equal symbol, so 3 is not colored in, 3 is open. If you're looking for something that would always work for both, because that's what and means, that means it's in between. So you're done. That's our graph. Okay, our new problem. It is still squished together, which means this is going to be a giant and problem. And we need to figure out what are the two separate inequalities that were actually squished together. The first inequality reads all the way until you run into the next one. So this is our first. To find the second inequality, you start immediately after the first one and you finish reading out the problem. So this is 3n plus 5 is less than 11. So now we need to solve the first inequality. Order of operations, so going backwards meant I had to pair this positive 5 up with a -5. -4 minus 5 is a -9. Less than or equal to 3n. Positive 5 minus 5 turn to 0, so they disappear. Now I'm going to divide both sides by 3. The minute you divide, you need to stop and take a look. This is a positive number. If it is positive, then you are not reversing the symbol. So I'm going to immediately write down the correct symbol so I do not accidentally forget it. -9 divided by 3 is a -3. 3 divided by 3 is 1, so I'm left with -3 is less than or equal to n, and now we have to come over and solve the second one. Order of operations backwards meant I paired this positive 5 up with a -5, so I have 3n is less than 11 minus 5 is 6. Divide both sides by 3. The minute you divide, you're supposed to stop and take a look. This is a positive number. If it is a positive number, then we are not reversing the symbol. So I'm going to immediately go down and write the symbol so I do not forget. 3 divided by 3 is 1, so I have n is less than 6 divided by 3 is 2. So we already had our first, and our next one is n is less than 2. So now I want to rewrite this as a squished together problem so I know what it would look like. All my numbers are being compared to the variable n. -3 was compared, and 2 was compared. When -3 was compared to the variable n, it was pointing to the -3. When n was being compared to the 2, my variable was pointing to the n. So this is our answer to the inequality symbol. Now I need to graph it. When graphing it, I need to be able to see both -3 and 2. So there's -3 and here's 2. I need a few outside, and I need a few outside. -3 is the number in question. There's -3. -3 had an equal sign, so this is closed. 2 has a number line. There's 2. There is no equal sign, so he is open. It's an and problem, which means I wanted everything that worked for both, which means it has to be in between the two. And you're done. So now we're going to start learning about the other words you can connect. So compound inequalities, our previous ones have all been connected by the word and. Now you can connect by the word or. So we have this problem, or the answer needs to work for this problem. So we are now connected by a giant or problem. And they're already separated. There is no way to squish them together and be a lazy mathematician. So we have -4 plus a is greater than 1, or we have -4 plus a is less than -3. We need to solve for these two problems and see what we get. So order of operations backwards meant I had to pair this -4 up with the +4. So I have a is greater than 5, or Pairing up the -4 with a +4, I have a is less than -3 plus 4 is 1. So I'm looking for all the times, for all the numbers that are bigger than 5, or those numbers that are smaller than 1. So if this were my number line, I need to have 5 and 1 both in my number line. So here's 5 and 1 being on my number line. 5 is the first number in question. Here is 5. It's not equal to, so it's not colored in, so this is open. What numbers are larger than 5? Well, I know 6 is bigger than 5, so for that one you would have shaded this direction. The next number in question is 1. 1's right here. Does not have an equal sign, so he is open. I'm looking for the numbers smaller than 1. Well, I know 0 is smaller than 1, so it would go this way. So if our ands went in the middle, our ors go away from each other. So you are either picking me or you are picking me. There's no way you can meet for both of us. It's ors. Since it's ors, they go away. And you're done. Here's our new compound inequality they want us to solve, and it's a giant or problem. Since it's a giant or problem, I know that my graph should be graphing away from one another. So here's my or, separating everything. Problem number 1, separated from problem number 2. So solving problem number 1, I need to get the x by itself, so I need to divide both sides by 2. The minute you divide, you need to stop and take a look. This is a positive number. If he is positive, you are not reversing the symbol. So I'm going to immediately write down the symbol so I don't forget. 2 divided by 2 is 1, so I'm left with x. Symbol's already there. It's less than or equal to. 6 divided by 2 is 3. So I am graphing x is less than or equal to 3, or coming over here, I need to divide both sides by 3. So I have x. I didn't look. This is a positive number. The minute you notice it's a positive that you divided by, we are not reversing the symbol. So I do not reverse my symbol. 12 divided by 3 is 4. So my first problem is x is less than or equal to 3, or I am now having to solve x is greater than 4. So my number line needs to be able to compare 3 and 4, and I need a few numbers to the left and I need a few numbers to the right so I can see. 3 was equal to, so 3 is colored in and closed. I needed all the numbers smaller than 3. Smaller than 3 went this way. 4. 4, no equal to, so he is open. I needed the numbers bigger than 4. Bigger than 4, well 5 is bigger, so it goes this way. Are these facing away like they are supposed to since it is an or problem? It is, they are, you're done. So we have another compound inequality connected by or. If it's connected by an or, I know that they should be facing away from one another. So here's me separating out my two problems. Problem number 1 was 2 plus r is less than 12. Problem number 2 was r plus 5 is greater than 19. So going through and solving these problems, I need r by itself, so I have to subtract 2 from both sides. So I have r is less than 10. So I need to graph r is less than 10, or, coming over here, I need to subtract 5 from both sides. So r is bigger than 14. So my first problem, or, now I have to graph r is larger than 14. There is no way to squish these into a lazy mathematician answer because ors just don't do that. So I'm now having to compare 10. So I need a few outside of 10. And 14. So I need a few outside of 14. When comparing 10, there's 10. There was no equal sign, so he is open. I needed numbers smaller than 10. 8 is smaller, so it goes this way. 14, there's 14. No equal sign, so it is open. I needed numbers larger than 14. 15 is larger, so I know it goes this way. It was an or problem, so you know they were supposed to face away from each other. They are. You double checked. You're right. You're good. So now they're switching gears on us. Now they actually give us the graph and they want us to come up with the compound inequality. So looking at the graph, I am now comparing all of these numbers to the number -1. These numbers over here, my shaded numbers, are being compared to the number 7. So now we need to figure out what direction to color in. So over here, number 2, we're comparing -2 to -1. Well, I know -2 is tinier. So if this side is tinier, it goes that way. This was colored in, so it equals as well. So all the numbers that are smaller than or equal to -1. Smaller than or equal to -1. Over here, 8 was an answer. It was shaded in. How does 8 compare to 7? So 8, is that bigger or smaller? 8 is bigger than 7. So we need the bigger. 8 is bigger than 7. He was colored in, so he's also equal to. So now we just need to know what word connects these. They are going away from each other. Since they're going away, it's connected by a giant or word. So our answer is x is less than or equal to -1, or x is greater than or equal to 7. There is no way to lazy mathematicians squish it together. So this is your compound inequality, and you're done. So the next compound inequality graph that they want us to come up with an equation for, all of my shadings are compared to this number 0. All of these shadings are being compared to the number 6. So I've noticed shading didn't go this way, shading went this way. So one of the answers that was picked was 1. How does 1 compare to 0? Well, I know 1 is bigger than 0, so 1 is bigger than. This is colored in, so there's also an equal to sign. So this is the symbol, x is greater than or equal to 0, for this dot. Now everything compared to 6. Nothing was shaded over here. This is not an answer. Shade 5 was shaded. So you're comparing 5 to the number 6. Is 5 bigger or 5 tinier? 5 is tinier, so you need the tinier than symbol, the less than symbol. This is not equal to, so it is not colored in, so no equal to. These are in between each other. In between graphings are and problems. So we have x is greater than or equal to 0, and x is less than 6. And problems can be squished together. Both of these were comparing themselves to the variable x. 0 was comparing to the variable x, and 6 was comparing to the variable x. When we were comparing x to 0, the inequality symbol was pointing to the 0. The inequality symbol still needs to point to the 0. When the x and the 6 were being compared, the inequality was pointing to the x. The inequality is still pointing to the x. These are our inequalities, and we're done. Okay, our next graph that we need to go ahead and try and find a compound inequality for, we were comparing all of these shadings to the number -9. We were comparing all these shadings to the number -2. There was no shading over here. The shading was on this side with -8. So we're supposed to be comparing -8 to the number -9. -8, I know, is actually bigger than -9. So this is the bigger than symbol. Not colored in, so there's no equal to. So x is greater than -9 is how we shaded this way. The other problem, there's no shading over here, so that's not an answer. -3 was one of the answers. So we are comparing -3 to the number -2. -3 is tinier than -2, so I need the tinier than symbol. Not colored in, so it's not equal to. So x is less than -2. The shading's in between, which means it has to work for both of them. So it's an and problem. So I have x is greater than -9 and x is less than -2. And problems are lazy, and we could actually mush them together. So both of them were compared to the variable x. -9 was compared and -2 was compared. When -9 was compared to the variable, the inequality was pointing to the -9. The inequality is still pointing to the -9. When the x was compared to the -2, the inequality symbol was pointing to the x. The inequality symbol is still pointing to the x. Those are our compound inequalities, and we are done. Our last graph that we are having to find the inequality for, all of these shadings were compared to the number -3. All of these shadings were being compared to the number 2. So now let's figure out what inequality symbol would go in here. -4 was one of the shaded numbers. So how does -4 compare to the number -3? -4 is actually tinier, so there's a tinier than symbol. It's colored in, so that meant that there was also an equal to in there. So x is less than or equal to -3. Coming over to the next shading that we have. You shaded the number 3, so somehow 3 is being compared to 2. 3 is bigger than 2, so we need a bigger than symbol. It's shaded in, so there's also equal to there. So this is x is greater than or equal to 2. They are going away from each other, so this is a giant or problem. It's either me or it's over here. You have to pick one. So x is less than or equal to -3, or x is greater than or equal to 2. There is no way to squish these together and make them a lazier answer. So this is it, and you're done.
What did we learn today? I can solve compound inequalities in one variable. I can graph solution sets of compound inequalities in one variable. And I look forward to seeing you tomorrow in class.